Okay, do you remember? So, part A, explain what is meant by centre of gravity. Who remembers that one?
Find where the mass
Almost, but centre of gravity, not centre of mass. No, it's fine, there's centre of mass as well. Centre of gravity? Do you want to slightly alter your definition?
the point is
It is the single point at which all the weight of the body appears to act. Almost there. Yeah? I won't write that down. Let's get to the calculations. Because the definitions are just something you can look up in your notebook. That's not what is important right now. Okay, B1. A trap door is made from a piece of wood. It's attached to a hinge. It's held in position by this force and this and this. Okay, so all the forces are on the diagram. What's the mass of the trap door? In other words, what's the weight? Alright, so let's draw this trap door. We have our door. And I'll put the forces in blue. Force 1. Force 2. And force 3. So it goes this way. This way, and this is badly drawn. Because they should all meet. Yeah, yours is badly drawn as well, is it? So they should all meet. So this force here, P, we don't know. And the angle here, we don't know. I'll call it theta. This we know is 35.6 and this is 40. This is 90 and this is W, which we don't know. Yep.
In diagram, I don't think they will be.
I know, because it's just a diagram. It's not supposed to be accurate picture, you know. But we know that they do meet from our lesson on this. Yeah, we can't trust the diagram. You know, just because it doesn't look like they meet doesn't mean that
But
they
then
won't.
they say that it's not to scale, something like that.
No. They should say that. They should say that, but they don't. They should.
They're gonna mess up with it.
No, they're not. They're not. This is 3 forces because how many forces are acting on it? Yeah. Yeah, indeed. Right, now actually we know this distance here is 0.39, and then since we know the total is 0.85, we probably have 0.46, yeah? Now, I can actually calculate this length here, because if I call this h, I can say tan 40 equals h over 0.46. So h equals h equals 0.386 meters. Now look, if I know these two, then I know the angle here, don't I? Yeah. So I can say theta is tan inverse 0.386 over 0.39. So that's 44.7 degrees. Yeah? Okay. Now what? We need to maybe get components, do we? So if I take my P, I can break it up into P cos theta and here P sin theta. So we can say that P cos theta must equal, oh, and I can do the same thing here, 35.6 cos 40. The horizontal here. Oh, KJ, get glasses. Here. Yeah? Right, so, do we know the theta? We do. So I can know the P is, in fact, again, listen, this is one of the examples where doing the second part first was actually better. I'm actually doing part 2 here. P is 35.6 times cos 40 divided by cos 44.7. So I get P is 38.4 newtons. Or the book, they do it, yeah, that's fine. Alright, so now we can get part 1. Because I can say this plus this one here should equal W. So W, this is part 1 now. W equals P sine theta.
Why did you use cos theta?
Here?
Yeah.
I did. I rearranged it and got the P. I took that under.
What are you gonna have?
The heck is this thing here?
Oh yeah.
P sine theta plus 35.6 sine 40. But weight is mg. So if I just divide this by g, I can get the answer. Right, so P 38.4 times sine 44.7 plus 35.6 times sine 40 divided by 9.81, and I get the mass is 5.09 kilograms. If you see in the book they took this answer to 4 significant figures, but the exam says your answer should be to 3 significant figures, so that's why mine is a tiny bit different. 5.086, so that would be 5.09 kilograms for me. Okay, so that's part A and B. Now on to C. An object. So you've got your mass here. It's 10.85 kilograms, and there's 125 newtons of force, and this is for 0.2 of a second. What is the velocity? Well, we can use F equals ma. The A is F over m, which is 10.85 over, nope, it's 125 over 10.85. So that's 11.52 meters per second squared. So we have U is 0, V is what we want, A is 11.52, T is 0.2, and S we don't know.
That should be good.
Thank you. Okay, we want the V. So V equals U plus AT. V equals U plus AT. The U is 0, so it's just AT, which is typed it in wrong. 2.304, so 2.30 meters per second, which is wrong. My A is right. No, it's right, sorry, 2.3. Yeah, that's correct. Okay, next. It then collides. So this is a baby collision question here, for babies. We have our 10.85 collides with B, and B is 15.62. And the B is moving this way with 3.67, and the A is moving this way with 2.3. And then after the collision, they move. No, they're not together after the collision. After the collision, B moves in the same direction, but with a speed of 1.2, and then of course A will be moving in this direction as well. So what happened was A hits into B, and A gets bounced around, and then it heads to the left. I'll call that V1. Or minus V1. It doesn't matter. If I call it V1, my answer will be negative. Well, the question is the new speed and direction. So I already know the direction. It has to be heading to the left. So I just need to find the speed.
It cannot pass through this.
No, it can't pass through B, so it has to be heading to the left. Right, so 10.85 times 2.3 minus 3.67 times 15.62 equals minus V1 10.85 minus 1.2 times 15.62. So the speed equals, and it's to the left. Okay, let's see. 10.85 times 2.3 minus 3.67 times 15.62 plus 1.2 times 15.62 divided by minus 10.85. So I got 1.25 or 1.26. Yeah.
Which is right.
Well, the answer is 1.24.
Because you forgot it's 1.21, maybe.
1.21?
Yeah.
Oh, it's 1.21.
Yeah.
Ah. So I'm missing a. Here there's a 1.
Yeah.
Thank you. So I'm sure that will fix it up. There's a 1 here, 1.21. Alright, so that's 1.24. So in fact the marking scheme here wouldn't get full marks because it doesn't actually say in the answer, although he draws away a picture, I suppose. Well, I would want you to say in the exam the direction, since I asked for it. Anyways. Next part. What is the change in the kinetic energy of objects A and B? Alright, so well, it'll lose kinetic energy. It'll be a half m1 v1 squared plus a half m2 v2 squared. That's the kinetic energy afterwards. So let's calculate that. And then the kinetic energy beforehand will be a bigger number. Right. And what's mass 1, please?
10.85.
And speed 1? V1?
2.3.
2.3, yeah? Plus a half, and mass 2?
Yeah, 15.26.
And speed 2? We just got it. No, we didn't. 3.67. Right, so the energy after the collision is 131.5 joules. And then before the collision, no wait, that's before, is it? Did you give me the speeds at the start, was it? Yeah, so that's this one here. 131.5 joules. Okay, and then after the collision, what are the speeds? What's V1 after the collision? That's 1.24, isn't it? And then V2 is, what's V2? 1.21, correct. So then after the collision, it's only 19.51 joules. So there's a big difference. The loss in kinetic energy is 112 joules. And here they have 114.3. Yeah.
Did you change the answer to 1.24?
In my calculation?
No, like the last time you took 1.21 maybe.
I took 1.24, and that was for the 10.851. Yeah, and then for the other one it was 1.21. and the mass is 15. Oh, no, my bad. I typed in 15.26. It should be 15.62. Right, so I think that'll fix it up. That's actually 19.8. And then this one here will be a bit different as well, so. What were the speeds at the beginning?
2.3 for U1.
2.3 and
3.67.
3.67. Calculator blunder. Are you sure? 2.3 and 3.67. Now this is still a bit different, but
Maybe it's because 3.67 is in opposite direction.
yeah, but it's squared, so the sign doesn't matter then.
Yeah.
I got here 133.9. Yeah, okay, so now it's right. 114 joules if you do three significant figures. Right, and lastly, why is there a difference of 114 joules in the kinetic energy? Well, 114 joules of kinetic energy was converted into heat. Heat, not only heat, but heat and sound. Alright, let's have a look at B2. Close this?
Yes.